Hello engineers, welcome back. In this video, we're going to start a new topic which is called 2D vectors. Hope you're ready. Let's get started. So here in this video, we'll see what are 2D vectors and we will perform all the crud operations on them, and then we'll discuss time complexity of each operation. Okay, so let's get started. 2D vectors. So let's recap 1D vectors for a second. So when we said int vector like this, and let's say we initialized it with 1 2 3 4. So as we know, in the RAM there is a new block of memory that is holding 1 2 3 4, and this is V. And if I add a new element through pushback, if I add an element called 5, now because this current block is full, there is a new block that gets created with 8 elements, right? 0 1 2 3 4 5 6 7. So there are 8 elements, and the previous elements gets copied here, 1 2 3 4, and the new element is now inserted here. So this is the capacity. New capacity is 8 and current size is 5. So this is how resizing of a 1D vector used to work, right? Now when I want to create a 2D vector, so when we say 2D vector, it means that inside every element there is another vector. So if I declare it like this, vector of, instead of int, I will declare another vector inside, and that vector can be int, char, anything. If I do this, and let's say I'm initializing it like this, first one will have 1 comma 2, second one will have 1 comma 2 comma 3 comma 4 elements. So I can do like this. Okay, when I do this inside RAM, what happens is there is my main vector which is holding the addresses of the first inner vector and the second inner vector. So these are addresses, which means there are pointers pointing to the inner vectors, and inner vector can be somewhere else. So V of 0 can be here. So this can be the V of 0 block, and V of 1 can be at some other place. So this is V of 1, and the pointer to V of 0 is here. The pointer to V of 1 is here. Okay. So that's how multi-dimensional or two-dimensional vectors work. Okay. So let's see how we can put data into such a vector, how we can read from it, update a vector element, and how we can delete a vector element. Okay. So since we are already familiar with C++, we'll directly jump into the code editor and then we'll learn from there. Okay. Let's go to VS Code. So I have already created a new file called 2D vectors, and I have included the vector header. Okay. So before we begin, I want to show you something. If your current VS Code settings are not using the latest version of C++, the C++ 11 version, here's what you can do. You go to the extension code runner, you can go to extensions and go to code runner, and then click on settings, go to extension settings, and then go to executor map, here, executor map, and here in this map, look for C++. This is the command that is getting executed when we hit the run button. And here, after G++, you just need to add this little thing, C++ 11. Okay, this tells the compiler to use this version when you're running the C++ command. Okay, So if you do that, you can happily use 2D vectors. So now let's declare a 2D vector. So vector of int v. So my 2D vector is ready. Now let's push the first vector into it. V dot push back, and instead of element, this will be another vector. So let's call it 1, 2, 3, and let's push two more, 3. Let's call it 4, 5, 6, and 7, 8, 9. Okay. So there is one vector with 3 pointers. Each pointer is pointing to an individual vector. Okay. Let's run it and see. Okay, done, no problems. Now let's create a function to print the whole vector, right? We can reuse that function multiple times. So let's create a function, let's call it print 2D vector, and we will pass in the vector of int, and we can directly take it by address because we don't need to make a copy. And how do we print it? First, we take the first row, print all the elements. Then we take the second vector, print all the elements. Then we take the third vector, print all the elements. So we can use two loops. This is the first loop, int I equal to 0, I less than v dot size, and I plus plus. So v dot size is holding the number of vectors. Okay. And when we go inside, v of I is holding the vector based on the current index. If I is 0, this is v of 0, and v of 0 is holding this vector. V of 1 will hold this vector, v of 2 will hold this vector. Okay. Now I'm here. Now here I need to iterate over each element, right? So I can use the second loop. For int j equal to 0, j less than v of I dot size. That is the size of the inner vector, j plus plus. Okay. Now I simply need to do cout v of I and j. Oops. V of I and j. So we are essentially going to the ith row and jth column. So if both I and j are 0, we are going to the 0th row and 0th column, right? Because these are the 0 indexed. Okay, so after every row I can do cout and del, so that we can clearly see that tabular structure. And we can also neatly do cout start of print, and we can do of end of print. Because we're going to reuse this, we can see the outputs clearly. Okay, so let's use that to print. So we print 2D vector, and we pass our vector, and let's run it. Okay, so start, we have 1 2 3 4 5 6 7 8 9. Let's actually give a space so that it's more visible, easy to see. Yeah, so you can see there is a nice matrix type of structure printed. Okay, so let's reuse this. So far we have seen how to create a vector, how to add elements to it, and we have also seen how to access elements. So we are basically using the index syntax, right? This is v of ij saying v of ith index and jth index, right? So that's how we do it. So how do we update an element? Let's say this is create, this is read or access. Now we are updating an element. Again, we can directly use the index notation. So let's say I want to update the last element. I want to make this 10. So I can go to the second row. This is 0th row, this is first row, and this is second row. and I need to go to the column. This is the second column. This is 0th column, this is first column, this is second column, and I can make it 10. Okay, now let's print the vector again. Okay, see, initially it was like this. Now our element is updated. Okay, so that's how you can update any element. You just need to access the correct row index and the column index. Okay, so now let's see how to remove an element. Again, to remove an element from a vector, we use the erase method, right? So we can use v.erase, but we actually need to point it to the correct index. Okay, so let's say I want to remove the element 10. I don't need it anymore. So erase function takes the iterator object, right? Takes the vector iterator. So first we need to get it to that stage. So we say we at least know the row, right? This is second row. So we are at second row. We start at second row and then we go all the way up to 2. So v2 dot begin will have 0. It starts here, plus 2 will end up here. Okay, so this is where my element is. We need to provide this element to the erase method. So now I can call the erase method on this. Okay, so vector dot erase. Vector is v of 2 and erase is taking the element, right? And that's it. So let's print it again. Okay, in the third print we can see that there is no 10th element, right? It has been removed. So that's how you can remove any element. You just need to provide the correct index. For example, if you want to remove the number 5, you will start at vector of 1 dot begin plus 1, and then you will give arrays on vector 1, right? You can print it. See, 1 2 3 4 6 7 8 10. Okay, so that's how you can delete. So those are the CRUD operations, right? So we have covered pretty much everything. We discussed what are 2D vectors, we discussed how to create, how to read, how to update, and how to delete. Now let's discuss time complexity of each of these operations, right? So when we say create, there are two things happening here. First thing is, if I have capacity, if I have some additional space, and if I do v dot pushback of 6, 6 can directly come and sit here, and this will be O of 1 operation, right? So there is a chance that it can be done in O of 1. But when the capacity is exceeded, like here, when we already had 4 elements and there was a 5th element to be inserted, so there was a new block that gets created and every element got copied, right? So this is n operations. Depending on the size of the previous vector, there can be n elements that need to be copied. So it is O of n. So create can be O of 1 if capacity is available, otherwise it will be O of n. Okay. Reading is straightforward. You just give the uh, index and we can read the particular index. If you're reading the entire vector, obviously it will be O of n because you're iterating through the vector and accessing each element, right? So depending on each vector size, this number changes. So if there are n vectors inside the 2D vector, so we can call this O of n into m, or this varies, right? So m is the size of outer vector, n is the size of inner vector. So it depends on the number of elements you're trying to access. Next, update. Update is O of 1. There's nothing to do here. You just go to the element index wise and then change it. So there is nothing else to do here. So that is O of 1. Delete. Delete can be O of 1 if you are directly, let's say, removing this element. There is no shifting involved, right? This space remains empty and that can be reused. So no shifting involved. But if you're removing the first element, then all these elements need to be shifted. So that can become O of an operation, depending on the size of the vector, size of inner vector. There is another case here. If I want to delete the entire row, if I want to delete this whole piece, then all these vectors need to be shifted. Whatever are the remaining vectors, they need to be shifted. So that can also become O of M, depending on size of outer vector. Okay. So that's how time complexity changes depending on the situation. Okay. So I think that's it for this video, guys. This is the introduction to 2D vectors. So as we know how to use 2D vectors now, we can start solving problems involving more than one dimension in a vector. Okay. If you have any questions, please definitely ask me. Do leave a like if you found this helpful, and do comment and let me know your thoughts and questions. And don't forget to subscribe to the channel if you haven't done already. Don't forget to bookmark the playlist so that you don't miss out on a future video and you can learn in sequence. I'll see you in the next video, guys. Thank you so much for watching. Cheers.